record this part. So this is actually a real scenario. If you listen to crickets outside, the warmer it is out, the more chirps per minute you hear, which is kind of cool. So you can kind of guess the temperature by counting how many chirps per minute you hear. And this has been documented in a lot of scientific studies. So what I'm going to do is I'm going to use the data given in my version to come up with an equation for a line. And so I just want to walk you through that process again for this one, give you a kickstart on this homework problem. And then we'll take a look at the share your work for this week. So in my version of the problem, I have on a 50-degree day, I measure 52 chirps, and on a 74-degree day, I measure 148 chirps, and that's chirps per minute. And then based on this data, we want to write a linear equation that will output the number of chirps. Okay, so this is the point where I start trying to put together a table and use that table to come up with an equation. So for this one right here, for my X column here, let's see, determine the output is the number of chirps. So that's my Y, chirps. And then given the temperature, so that's the independent variable. So this one right here is my temp. And the chirps is actually chirps per minute. The temperature.
And then the independent, will that one be changing all the time?
The independent here is going to be the temperature.
Okay.
So the temperatures just kind of change and out of our control, and then we're watching to find out how many chirps they have.
Okay.
And that makes good sense here, right? Because the crickets don't really change the temperature. Like if there's 50 crickets around me and it's 70 degrees, it's 70 degrees because it's 70 degrees because of the sun and the wind and all that stuff. Yeah, so that dependent would be the chirps, independent would be the temperature.
Perfect.
And they're saying what letters? T instead of an X and an N instead of a chirp. And we need to come up, so again, my goal is something that looks like this, Y equals mx plus b, where we need to calculate m and b and then replace the right letters for x and y according to the problem. So first thing we do is get the table set up so we can make our slope. So 50 degrees led to 52 chirps for me, and 74 degrees led to 148 chirps. So for me to find my slope, m, I need to figure out what is 148 minus 52. I always make sure the y values end up in the top. And then since I started with 148, I have to start with the corresponding x value, so 74 for the temp, and then minus 50. And I don't really need the numerator and denominator separately, so I'm just going to type it into my calculator as is. So fraction 148 minus 52, and then 74 minus 50. I think I typed those correctly. Yeah, looks right. And I think the calculator said it was 4 on my calculator.
Hi.
All right, so then let's see, the y value, just sometimes I like to state what that means. The numerator, those were my chirps. And denominator was the temperature in degrees Fahrenheit. So I'm going to say degrees Fahrenheit. So that would be 4 chirps per 1 degree Fahrenheit. So every time the temperature goes up by 1 degree, I should hear 4 more chirps per minute. So if I was hearing, 60 chirps per minute, and all of a sudden I realized the temperature went up a degree, I should now hear 64 chirps per minute. That's what the slope tells us. To find the y-intercept, the b, we need to pick one of these points, and I think the first one looks easier. I like those 2 numbers. The y value is 52, so we're going to plug in y as 52. We just calculated m is 4, and x is 50. And make sure you get the y and the x in the right spots. Every once in a while I screw that up. 4 times 50, 4 times 5 is 20, so that'd be 200. So we'll have to subtract the 200 to the other side. And so it looks like B is negative 148. Looks like it. All right, so then my equation, I'm running out of room to write that. Let's stick it over here. Y is going to be n here. So I'm going to get n equals 4. Instead of an x, they told me to use a t. And notice I always try to write that down in my table so I get it right. And then minus 148. Now the starting point of negative 148, what does that mean? It means if the temperature was 0, right? Because that B goes with the point 0, like on the table, 0, negative 148 is what point that would be. If the temperature is 0 degrees out, there's going to be negative 148 chirps. You can't have negative chirps. So although it is a starting point, it doesn't mean anything in this case. So sometimes the y-intercept is meaningful, sometimes it's not. This one is not. Oh well. But
I have a question.
Yeah.
Does it matter what points you use to plug it? Like when you're trying to figure out B, does it matter which points you use?
It doesn't, no. So if I repeated this with the other points, then I would have 148 is equal to the slope 4 times, what was that one? 74? And this time I'm going to need my calculator, so I can't do that in my head easily. So 4 times 74, we should get exactly the same number.
So if like they're different, that means you did it wrong. Like
if they're different, yeah. So this is a way I check myself sometimes to make sure I'm doing it right. Yeah, so there's 296 for this right here. And then if we subtract that to the other side, so minus 296 on each side, we should see that 148 minus 296 is negative 148. So take that previous answer. Oops, no, I want that one. Clear. Take my 148 and subtract the number above, 296. There's the negative 148. Yeah, so it shouldn't matter which point. So if you do want to double check you got the right y-intercept, do it with each point and see that you get the same thing.
Okay. Thank you.
And then you know you're on the right track. Oh, a warning on that, Alex. If you rounded the slope, like maybe the computer said, the problem said, hey, round the slope to 3 decimal places. If you had to round, then the y-intercept from one point won't be exactly the same as the other one. Like one might come out to 147.9 and the other one might come out to 148.
Yeah, because I'm actually having issues like the homework, like 3.5, like the last question.
Mm-hmm.
I'm having issues with it, so I'm trying to figure it out. And
okay,
well,
let's look at that problem next. So it's the last question, homework 3.5?
Yeah.
Okay, so we've mostly answered this question anyway. And then we'll back up and look at that one. So I got an equation here, n equals 4t minus 148. And then the next step would be to plug in 96 chirps. So that would be my n, and then solve for t. And so you guys are getting better at solving equations. I'm going to leave that one for you, but that would be the last step here. So for the next part, part B on this problem, I have the equation n equals 4t minus 148. They told me there were 96 chirps, I think, in my example. Yep. So I would just replace the n with the 96 and then solve this equation for t to guess what the temperature was. So I'll leave that as an exercise to you all. All right, so it's a last question, homework 3.5.
Yeah, and I also had to redo it a few times, so I don't know if it's a different problem.
Yeah,
I guess
number,
it's
yeah. So
same
I'll get similar numbers, but not exactly the same when I look my version up, which is all right. Zoom.
Our homework assignments are a lot of points.
What's that?
So their homework assignments are a lot of points.
There are a lot of points.
Yeah.
I do them all, Cody, because I'm so afraid I'm gonna flunk the test.
Yeah, I agree. Me too.
You're not gonna You do work in a timely manner, you'll be fine in this class. I've never had anyone that tried in this class and failed, ever.
Never.
Okay. Never, no. Everybody that tried everything passed the class. The
Okay.
only people that have failed the class is the people that blew stuff off. They just, I'm not going to do those assignments. And that's why they didn't pass. So you're doing good. All right, so this one is pretty similar. We just got slightly bigger numbers, and rounding could cause an issue. So let me try my version, and yours will be similar. The numbers change and the things we're producing change a little bit, if I remember right for this one. But it's the same process.
Yeah, that's why I was able to do so well on the Benton County one. Even though you gave a fake county, I could just follow your directions. But last time I don't know if you've corrected that or
I'm behind on grading. I gave too many assignments in all my classes last week. I'm playing catch up.
Oh, I'm not complaining or anything. I haven't even looked. I'm too scared to.
Don't be scared. You're going to be fine. Okay, so let's get this one done here. So let me see. What do we got? We're producing canisters. They find that if they produce 190 canisters in a month, it costs them $8,610, and to produce 340 canisters in a month, it costs $11,460 total. And we want to find an equation y equals mx plus b, where x is the number of canisters. All right, so as usual, the first thing I do in a problem like this is I start making a table to summarize the information. And no matter what letters they give me, I like my X's and Y's at first, and then I like to state what they are. So X are my canisters, and Y is the cost. Okay, so my dollars there. And I know that 190 goes with $8,610, and 340 goes with 11,460. And so as usual, the first thing we do is we find the slope. So slope M, and like I write this stuff down for you guys. I'm expecting when you do your homework, you're writing stuff like this down too in a nice notebook, so you can look back at it when you need to. Don't be in the habit of just whipping out your calculator and start pushing buttons. Write it down first and then hit your calculator. So the Y values always go on the top, and the order doesn't matter as long as whatever Y value you started with, you better pick the corresponding X value to start with in the bottom. All right, so then I just type that into my calculator, see what it comes out to. And I'm gonna have to do that on the side here and then come back because I can't keep that all in my head at the moment for some reason. Okay, so I'm just going to type this in and check with you guys. See if we agree. Okay, so according to my calculator on this one, I've got the right numbers top. Yeah, that looks good. I get 19 for the slope. So if you were playing along too, hopefully you got the right number. Now I didn't have to round, so I should be okay. Sometimes rounding can be a little bit of a problem, but usually not much. All right. There it is. All right, so we have a slope of 19 in this case. And then let's see, the numerator was dollars, the denominator was containers. So this would be dollars per container, if I need to know that. Next is the y-intercept, so that's where I plug into y equals mx plus b, and it doesn't matter which point you pick as long as you get the y in the right spot. So I'm going to go with the first point just for the heck of it. 8610 is my y, m is 19, and x is 190. So I need to multiply and then subtract to get that result. So I've got 19 times 190 is 3,610. And so then I want to take that away on the other side. 3610. there. So now we're going to subtract this over, and that's B. And it again, it shouldn't matter which point we pick. 3610. So I'm going to take my 8,610, subtract the number above, 3610, and I get 5,000. So it looks like I have an equation. Y, the cost, is 19 times X plus 5,000. So just a note about the two numbers I got here. This right here is a variable cost. Right, that's my $19 per container. And then the other number is the fixed cost. Right, before they start making any containers, it's going to cost $5,000 to get everything set up to make containers. All right, so did answer the question, and I hope that helped, Alex. So here I should just be able to type 19x plus 5,000.
Yeah, I still got it wrong, but I think I don't know what's going on. I know it's better than what I was doing before, that's for sure. I'll just try to do like a different number for like, you know, similar question.
Yeah, and again, for me to get these right, I got to write all this stuff down. Otherwise, I'm sure.
Yeah, see, I did that. I just like
Okay.
the previous
So you just have a
times,
calculation error somewhere.
I estimated like you're saying, like, and it just kind of messed everything up. So,
Okay.
yeah.
I think you got the right idea now.
Yeah, I do, sure.
Okay. All right, so let's take a look at the share your work problem for this week. And then that'll be it for today. I'm just going to hang around and answer questions if anyone has them. So home. And oh yeah, don't forget, when you're in the homework and you know some kind of question comes up and we're not in class, you got that message instructor button. So don't be afraid to use it. So if you're not getting something right after a couple tries, message me. Tell me what you tried and I'll get back to you. Okay, so share your work. So what I'm going to do is I'm just going to take a look at this problem and then I'm going to do a similar problem with you. So I think I told you guys before, in my free time, when I have free time, not often lately, I like to bicycle, and usually I like mountain biking over road biking. So Shane is a guy I bike with once in a while, and most people that bike a lot have these computers on their bike that keep track of, you know, how long did they bike and how far did they go. So I got some times from Shane's bike computer. And what I want you to do is I want you to graph this data right here. The easiest way to do it is in a spreadsheet. So I'll go over how to do that on a spreadsheet, but you can totally do it on paper, a piece of graph paper if you have it, if you're careful. And so the grade for this one here is going to be, did you make a decent looking graph of this on paper or on a spreadsheet? And then after that, we just have to pick 2 points to find a line.
But is the time the X?
So whenever I make a table of values, the first column is always the X's and the second column is always the Y's.
Okay, that's what I thought, but I thought.
It's always independent variable, dependent variable.
Okay, that's what I was hoping that I had it right.
Yeah, so I'm going to do a similar problem to this. I'm going to pull out some of my mountain bike rides from last year, and we're going to go through the same process here, okay?
Okay.
So here is some of my rides.
Are we recording this?
Yep.
Yeah, it's being recorded.
And I actually already have a recording of this too, already in the playlist.
Oh, because I've looked for share your homework 4, and I didn't see it.
Okay, I will share that video with you after class, the previous one and this one.
Okay, thank you.
All right, so here are my rides here, and this group of numbers, I put them in order. And you should notice that for Shane's ride, they weren't in any particular order in terms of time. Like maybe he rode this one a month ago, and this one was the week after that, and that was the week after that. So keep in mind, the order in the table is not going to be the order on the graph necessarily. So again, you have to decide if you want to graph these on a computer or if you want to graph them by hand. I'm going to show how to graph it in a computer. I'll show it in Google Sheets and I'll show it in Excel. So for example, with this data right here, you should be able to highlight from time and hours down to the last number. You should be able to copy that and paste it into any spreadsheet and it should look just fine. So I could take Shane's data and just put it in my spreadsheet, just like I have.
It's a lot faster. I tend to just go page to page and just type.
Yeah, you could do that too, but yeah, but copy and paste works most of the time on different documents.
But on your hours, I like it where it's not all mixed up.
Yeah, so then like for Shane's numbers right here, once I put them in there, I could tell the computer to put them in order. So to do that, I would highlight the numbers, and then in Google Sheets, I go to Data, Sort Range, and Excel works the same way. I have a header row, I want it to sort the time, and then I hit Sort, and then it reorders them in terms of the smallest time to the largest time. So
Okay.
I'm gonna go do that with these numbers here, but I'm gonna do it in Excel this time.
Oh, thank you.
Excel users out there. All right, so I'm going to start with a new blank sheet. And let's blow this up so you can see it better. Should be big enough. And so if you copied it right, you should just be able to paste the stuff in there. Let's just make this a little bigger so I can read. There we go. And if they weren't already in order, what I would do is I would highlight all of it. And sorry, my Zoom screen's in the way. And then I would go to Data and then Sort. And then it works pretty much the same way. It says, it's already checked the box. My data has a header row. So then I just say, hey, sort the times for me, please. And then I hit OK, and it will reorder them for me if they weren't already in order.
Thank you.
And all right, and once we have that, we create a graph. Now, creating a graph, I've demonstrated that a couple of times. You highlight, I like to highlight the titles too and all the numbers, and then insert. And often recommended charts gives you the right one, but lately Google and Excel have been giving me this line chart. I don't want that connected line chart. I need a scatter plot. So then I switch to all charts and I grab a scatter. And looks like the second one's probably better.
Is the XY scatter plot?
XY scatter plot, correct.
Okay.
All right, so then I have those here. And again, you could do this on a piece of paper too. You just have to carefully line out your scale. So just be super neat if you do it on paper. One problem with this graph is it's not labeled well, and labeling things sometimes on a spreadsheet is a pain in the butt. And I did ask that the graph be labeled. So there needs to be a label as to what these numbers mean here and a label as to what the numbers at the bottom mean. So in Excel, I think the plus button does it. And I want axis titles, and then it gives me places to type. So then down here, I can type over that. In hours, and then over here, if I double click, sideways, distance in miles. So make sure you label your graph. Distance. All right, oops, I didn't need to hit enter. And that's really all I need to do to fix this one. I'm gonna go back, I'm gonna do the same thing here. In my Google Sheet here, works exactly the same, almost exactly the same way. Highlight, insert, chart. And hey, Google guessed I wanted a scatter plot. If it didn't, then I would go through the list until I found scatter, and then I would select it. That top point's kind of getting chopped off. That's freaking me out. So to fix that, I have to go, I did this the other day, I have to go over to customize, and I want to adjust the vertical axis. So I want it to go a little higher. It's cutting off at 12, so maybe I'll go up to 13, see if that looks better. That looks a little better. Okay. So sometimes you have to play with the settings in the graph, and that's just pushing buttons till you find the right spot. So if you're doing this in a spreadsheet and you can't figure out which button to push to make something appear, message me. I'll get back to you and help you with that. Okay, so that was part of it. Either graph this by hand or graph this on a spreadsheet. Next thing, I need to pick 2 points to make a line through here. So the question is, which 2 points do I want? So in my room right now, I got a piece of paper, and I'm holding the paper up to my screen to try and pick 2 points. Okay. I'm gonna pick this first point here and the second to last one, because that looked good. So I'm just gonna show you that on a piece of paper here. Let's get a screenshot of this. So if I graphed them on paper, I would use a ruler or a piece of paper as a straight edge. Let's put it in a new page. So I was holding a piece of paper up to the screen, and the edge of my paper hit those 2 points, and that looked pretty good to me. I'm hitting 2 points. There's 2 points above. There's 3 points below. So I'm trying to balance points above, points below, but get this trend going here.
When you said hit 2 points, I made a line on 2 points.
Okay.
That was wrong.
You can't just randomly pick 2 points in the table, because if I accidentally picked these 2 points, right, that line is not the trend of my mountain bike rides. Okay. So
No, I just picked say the last 2 and only made a line through those.
Oh yeah, no. So you gotta find a line that fits the trend, right? And it could be your line hits none of the points and you make up new ones. Like, check this out. What if I decided my line was gonna be like starting right above, oh shit. That wasn't the line, try that again. Maybe I start right above that one. You know, maybe that's my line right there. So if that was my line, then I would have to make some shit up here. So I would have to say, okay, well, one of my points is going to be this one, and I would have to guess what that is. Maybe it's the point 1.3 and 12. And then over here, what would that be? Maybe that's the point 0.8 comma 7.5. I don't know, I'm just guessing.
How do you make a line on Excel?
You have to hold a piece of paper up to your screen. You're not going to make the line in Excel.
Picture of our graph, we need to draw it basically. We can't.
Yeah, so it's not.
Google, so.
Yeah, you can't. There's no easy way to make Excel draw your line for you. There's a fake way to do it. I can show you in a second if you want to see it. It's kind of weird, but I'll show it to you anyway. So
well, I have graph paper.
Yeah, so what I would do is the easiest thing for the line is to just plot the points on paper and draw the line on the paper.
Okay.
So the first thing I'm doing here is I'm just looking at my screen right now, like you're seeing it, and I'm holding a piece of paper for a straight edge up to the screen and estimating which 2 points I'm going to use.
Can we do the first point and the last point, or you said that's that causes?
Well, it depends on the data. So in this particular example, I didn't like the way the first point and the last point looked. So let me back up to my sketch here. Let's undo that scribbling I made.
So you want them to be as straight as can be.
Well,
that's why you picked those.
No, that's not. The line's straight no matter what. But you can't just randomly pick 2 points, right? Because if I pick the last 2 points, then my line's going to look something like that, which doesn't come anywhere near the other points, right? So if I pick the first and the last point here, I didn't like that because there's too many points above and no points below. What you want to do is you want to estimate a line through the points so you hit 2 of the points if possible, and you have about as many points above as below. So
Okay.
that's why I decided earlier when I was holding the paper up to my screen that the first, for this data set, and this isn't Shane's data, this is Gary's data, this is a different data set. For these points, I liked the first one and the second to last one.
Okay.
Now, somebody else might look at that and say, no, 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 the second point's better, Gary. And they draw their line from the second point to the second to last. So maybe somebody else says this is a better line. So I'm just going to shift, oops, shift that over a little. So somebody might decide to use a different pair of points than I did. Okay, so
And you
somebody
still
says,
have
"No,
some up below
that
and
point and
above.
that point are better." Yeah, so this is good too, right? There's now, so when my first one, I had 2 above, 3 below. This version has 3 above and 2 below, which is better. I don't know, they're both great. So it turns out there's lots of choices. You just have to pick a choice.
Okay.
All right. So so once I pick 2 points, so you got to graph them, decide which 2 points to pick. Once you, so this is kind of like the world record problem we did the other day. The next stage is to then calculate your line. Oops, my slides are out of order. So to do that, I need to then use the data. So let me screenshot this. New page. All right, so my last version of this, I decided that I was going to use the second to last point and, sorry, the second point and the second to last point. All right, so I just want to double check I got the right points. This one says 0.78, 6.35. So 0.78, 6.35, yep, that looks about right. And then the other point I picked 1.26, 11.99. 1.26, 11.99, yep, that's that one. So double check, you got the 2 sets of points right on the screen, on the graph, and right in the table, because that's a common place to mess up. Then it's just like before. First thing I'm going to do is I'm going to find my slope. What is 11.99 minus 6.35 divided by 1.26 minus 0.78. So I'm going to whip that out on my calculator. And actually, I can just do that in my spreadsheet because I have the spreadsheet. So I'm just going to highlight that one, and then I'm just going to put a note here for my slope. And on the spreadsheet, if you decide to use the spreadsheet to make the calculations, which it's optional, you have to do equals parentheses, this minus that, y values first, close the parentheses, divide, parentheses again for the denominator, and then subtract the 2 times. Close the parentheses. So the parentheses are super important. I'll write that on my paper too. You know, I don't want to autofill. So my computer says I picked 2 points that have a slope of 11.75. Whoa, I was writing pretty fast then. All right, so back to my notebook. So in order for the spreadsheet to do this right, I need parentheses here and here. And I got a slope of, I think it was 11.75, and that would be miles per hour, right? Miles per hour. So basically what I'm saying is based on those 2 points, my average speed is almost 12 miles per hour. And on mountain bike trails around here, that's pretty fast because there's a lot of uphill climbing. So I must have been in good shape when I did those rides. Don't think I could do that today. So next is the y-intercept. So this is my x, right? This is my y. So I'm going to write down y equals mx plus b. And then pick one of the points. And it doesn't matter which one I pick. I'm going to go for the first one. Y is 6.35. I just calculated m is 11.75. And the x value is 0.78. And since I started calculating in a spreadsheet, I'm just going to go back there to do that. So I'm trying to find b, my y-intercept, and the first step in that is multiplying that 11.75 by that 0.78. that right? That looks right. So that gives me 9.165. And so I'll have to then subtract that number over, see what I get. Desktop. So I guess that's not quite B yet. I guess I can just modify this. So then that's going to be subtracted. So I'm going to sneak in front of the equal sign and take that 6.35 minus that product there. And the subtraction, I get negative 2.815, which is weird, but we're going to go for it.
So you can keep the negative if it comes up.
If it comes up, it comes up, right? 9.165, I have to take that away. And that comes out to, what was it, negative 2.185, I think. Double check. Yeah, all right. And I'm going to show a couple of ways to check to see if that's a reasonable y-intercept here. Okay, so I got B. So altogether, I think the equation for these points right there that kind of goes through the middle of them is y equals 11.75 x minus 2.185. Now, remember here, this is supposed to be the starting points. It is a, B is a y value, y is miles. So this means Gary's starting at -2 miles. That's kind of weird, right? I start off wherever I start, that's 0. So this really should be 0, but to get the right line, that's just not going to work. So I'm just going to demo that on the spreadsheet. All right, so here's the way I can fake a line in here. I got to move this stuff out of the way. And I'm going to put a note here that I'm going to do my line here. And to do my line, I just go equals and I start typing my equation, 11.75 times, and I can't put an X here, but this column A are the X values. So I'm just going to click on that first X value there and then subtract the 2.815. And I do want to autofill, but if you're using Excel, you would have to click back on that and then drag that down.
Right.
Okay, so just to double check, I used this point right here to find the y-intercept, and notice it says, hey, 6.35, 6.35. So it should match there, because that's the point I used to find the y-intercept over here. If there's any rounding, this next one might not be an exact match, but I didn't have to round my slope. So if you had to round your slope, then what you would find is this number right here didn't perfectly match. Like maybe it came out to 11.98 or 11.97 or something like that. So then if I want to turn this into a line over here, I basically got to make a new graph. And so I'll do this in Excel too in just a sec.
Okay.
I'm gonna highlight that. But this is overkill. This is not what I intended you to do for this activity. I wanted you to draw the line on paper. But a spreadsheet can be handy except for this part. This is a pain in the A. So I'm going to insert a new chart. And it's, notice the red points are my new ones and they kind of line up there. To turn that into a line, all I do is go to Customize Series. And then I say for my line, draw a trend line through there. So then it will draw my line.
Oh.
Okay, kind of a pain. I'll do the same thing in Excel right now. So this is not what I intended you to do. It's just a cute spreadsheet trick for this example. This is not part of the project. Draw it on paper. It's way easier and more practical. Let's go to Excel. This is just Gary screwing around with a spreadsheet. So I'm going to delete that one. And let's bring up a new tab. Paste my data in, blow it up so you can see what I'm doing. So Excel, it's a little harder to make that happen, but it's similar. I highlight all of it after I, type the equation in there. And then, let's see, in Excel, it's insert. And since recommended charts hasn't been working for me, I can see the scatter plot right here. I'm just going to click it. And then the first one. Okay. All right. Now this part, let me see if I can get this right. Is it the plus button? Sort of. I think I need to click the point first. Yeah, click the point, and I think then hit this trend line option. There we go. And then it draws the line through my points there. See someone's chatting me. Okay, take care, Brennan. I was glad you could join us. Have a good day. Yeah, so I can make it happen. I just had to click the right set of buttons. But again, let me repeat. That was not what I intended to have you do here. Easiest thing to do is plot these on paper and draw your line on paper.
But we can still do this on like Excel and then graph it on the graph paper.
Yeah, so what I would do is I would do some of this in the spreadsheet, and then I would have a piece of paper with my line and the points.
Okay.
And some work written down. Okay, so I didn't go over everything. There's a couple things I want to go back to, but I got the basics done, right? I came up with an equation. The other things I have to do is I asked you to do a few things. I asked you to tell me what that number means right there. What does 11.75 mean? What does the negative 2.185 mean? And by the way, if like really the equation should be more like y equals 11.75 x, because x is time. If I spend no time biking, I shouldn't go anywhere, right? I'm just sitting on my bike. I'm not moving. There should be no distance. But this number up here is a point, and the point is 0, negative 2.185, like a point in my table. And it says if Gary spends no time biking, then he should travel negative 2 miles. What? That's crazy talk, right? That's nonsense. But I need that number there to shift the line into the right spot. Watch what happens if I ditch the 2.185 in my graph. Yeah, I can do that here. So if I tweak this calculation here, let's actually just do it over again. If instead I just go equals 11.75 times the time, and I just say, hey, forget about that negative 2. That's a crazy number. And then I fill that down. The line's going to be in the wrong spot. Notice it's way up here. Mm-hmm. I needed that negative 2.185 to shift the line down so it goes through the points. So although practically the negative 2 is not a useful number, it is very important to get the line in the right spot. So this new line has the right slope, but it's in the wrong spot. It's way up there outside the points. Mm-hmm. So it turns out that y-intercept is important, but the interpretation of it is just bullcrap. Yeah. It doesn't mean anything, but it's still needed. All right.
Maybe you rode backwards for a while.
Yeah, maybe I'm riding backwards, right? Yeah. Okay, so let's get rid of that. Let's get rid of that. Back here. All right, so let's see. I didn't write a definition for each variable, so that should have been in there. So back here, somewhere, I kind of have it right here. Like I said, hey, y is distance in miles, x is time in hours, but I really should write it out in a sentence somewhere. So maybe I have a page before this one, like there, and I would write, all right, let's let y be the distance Gary rides. In miles. For yours, you're going to talk about Shane instead of Gary. X would be the time of the ride. Time of a ride.
In hours. Hours,
yeah. Right, so tell me what your variables mean, and you can use any letters you want. You don't have to use X and Y, it's up to you. Graph them. Okay, so I had a graph on my computer. I'm going to put it on paper also because that's the easier place to draw the line. whether you do the graph on paper or the computer, make sure you label everything. So what does that mean? Well, it means that the vertical axis here should have some label saying what these numbers mean. The horizontal axis over here should also have a label saying, okay, that's time in hours. And this title up here sucks. I'm going to put in a better title. This is Gary's mountain bike rides. So give it a nice title, whether it's on paper or on a computer. Oops, no, I want it to be over there. Back here, what else? Yeah, so I'm going to draw the line on paper instead. I did it on the computer, but that was kind of a hack. I didn't really like it, but it works. I got my equation, and my explanation is my work, really. I mean, this explains how I got the equation right there. So that's pretty straightforward. Interpretation of the slope. What does the slope mean to Shane? Okay, what does my slope mean to Gary? And I mentioned that earlier. I made a note that the top numbers were miles up here, and the bottom numbers were hours. So then I should write a sentence somewhere. So let's go back here and put that in. So my M equals 11.75. Your M is whatever you calculate. And so this means Gary averages about 11.75 miles for each hour he bikes. For each hour he mountain bikes. Okay, and there's tons of different ways to word it. You find a wording that works for you. Like I could have said miles per hour instead of miles for each hour. So there's lots of different words there. I also asked for interpretation of the y-intercept, and this is important. A y-intercept is really a point, 0, whatever b is. So mine was 0, negative 2.185, and literally what that means, because this number here is hours, and this one right here is miles. This says if Gary, I'm not sure why I keep forgetting to capitalize my name, probably because I'm talking about myself, which is kind of weird. So if Gary spends no time biking, right, the 0, then he traveled negative 2.185 miles, right? And so that's nonsense. I'm just going to make underneath a note that says, this is nonsense. Now, it doesn't mean I can throw it away. I really can't. I need it because it puts the line in the right spot. Otherwise, the line's in the wrong spot, and it doesn't match my bike riding data. All right, let's see. So interpretation of the y-intercept, interpretation of the slope, an interval of ride times that's valid for your model. So what the hell does that mean? So remember yesterday I talked about interpolation and extrapolation for like the data about the boys' heights. That equation we came up with does not apply to 20-year-old boys, and it doesn't apply to 1-year-old boys either. So same thing here. I only have data for Shane from a little under an hour here to a little over 2 hours. So that's all I know for my equation. So for Shane, I would say, yeah, this equation only works for a little under an hour to a little over 2 hour bike rides. Otherwise, I really don't know, right? It could be that for half an hour, Shane can just sprint on his bike and go wicked fast, way faster than he goes otherwise, right? Sometimes I do time trials on bikes, and usually that's just like a 2-mile course, and I can do it in a few minutes. And I'm gonna get a way faster ride speed than I usually do. So it's a different scenario. And then what if somebody said, okay, let's make Gary go for a 50-mile bike ride. I'm gonna have to take some breaks if I'm biking for 50 miles. So it's gonna take me a long time. It's gonna take me all day probably. And that wouldn't fit the trend of my short rides. Okay, so that's what I'm getting at there. So if I look back at my data, let's go find my spreadsheet or my table. Where's that? Here. Yeah, so looking at Gary's data here, my data, the smallest ride was like 3/4 of an hour, and the longest ride was only an hour and 20 minutes, 1.33. And that, again, that's 33 hundredths, which is about 20 minutes, a third of an hour. Yeah, so this equation is only for times about 0.7 hours to 1.33 hours. I don't have any information about how far Gary can go in 2 hours, and I don't have any information about how far Gary could go in a half an hour. It's just not there. I don't know. It might not fit this trend.
So we don't have to do it. I mean, it's supposed to stay in that trend.
Yeah,
Right.
you have to stay within the data, right? And that's the bottom line. And usually we just look at the independent variable, but the dependent variable is relevant too. So if I look at my graph here, I can see that for the rides that I did for this data set, my times are, again, they're between like 3/4 of an hour and an hour and a third. And my distances are somewhere between 5 miles and 12 miles. I guess I got up to 13 miles somewhere. No, I don't think I did. I think 12 was the most I went. Yeah, 11.99. Yeah, so my equation is only relevant for distances between 5 and 12 miles. I don't know.
Hours and distance.
Yeah, so you could talk about the hours and the distance there. Yeah.
Okay.
Yeah.
How do you make it in order again? The
Okay, are you using Excel or Google Sheets?
sheets.
Sheets, okay. So in Google Sheets, what you would do is, let's undo this. Oops, that goes back there. I guess I'll recopy and paste it. So if I highlight this and stick it in Sheets, let's bring up a new tab. First thing you have to do is highlight all of it. So make sure you highlight even the titles in both columns. And then you go to Data, Sort Range, tell Google it has a header, and then it says, okay, you want to sort the times? A to Z means smallest to largest. Z to A would be largest to smallest. And so I would just do that. And the point about highlighting all of it is it makes sure the two numbers stay together in a row.
Mm-hmm.
It keeps the rows together. Yep. All right, other questions? All right, so we're out of time for fun with math today. When you do this, you may have a spreadsheet, that's cool, and then hand in a spreadsheet and maybe some paper or type some stuff up. Easiest thing to do for the line is to draw it on a piece of paper. Oh, and then make a prediction. What the heck does that mean? I forgot to mention that. So to make a prediction is to pick a time that's not in the table here. And again, interpolation, extrapolation. I wouldn't pick 4 hours because there's no evidence about what Shane can do in 4 hours here. So pick a number in here pick a number in this range here. So something between 0.8 and 2.1. So for my data back here, if I were going to do a prediction, so let's make a new place for prediction, then I would say, let's go exactly 1 hour. That's not in here. So if I could pick exactly 1 hour, my equation says, okay, take 11.75 times that 1 hour minus that crazy 2.185. And you may or may not end up with a negative number for the y-intercept. It's gonna be a little different. So that's my prediction right there, that if Gary rides for 1 hour, my equation predicts he'll cover about 9.5 miles. And so I would write a sentence that says that. Okay, so this recording will be in the YouTube channel later, and then Brenda had asked that I send out my previous recording of this, so I'll send that one out too. surprised I didn't stick it on this page. I usually do.
I looked for it. I
Okay.
really couldn't find it.
Yeah, I'll find it. Sometimes I didn't do the best job labeling the videos in YouTube.
Well,
I
no,
remember, I think it was on the other discussion because, yeah, it was like in the beginning of the video.
Okay, and I'll find that and I'll put it in the announcements again so everyone can see it. All right, so you guys take care, do good math. If something comes up, write me a message and I'll get back to you as soon as I can. And don't wait to the last minute to turn stuff in.
well,
Have a
thank
great
you for going
day.
on
You
with this.
too, thank you.
You're welcome. Oh,
Thank
Brenda,
you.
hang on for a minute. Don't go right away. I wanted to chat with you.
All right.
Thank you.
You're welcome. Take care. Okay, so hang on. Let me make sure I'm not recording.